So a further application of the chain rule is something called implicit differentiation. First, it's important to keep in mind that everything we've been doing so far you could call explicit differentiation. So for example, when we have y as a function of x, that means that we have an explicit expression for y. We know exactly what y equals in terms of x. And so all that is needed to find y prime is just to take a derivative of the associated expression of x. Well, sometimes we have expressions like this, where really, for all intents and purposes, we can't solve for y. We can't get y by itself. It just is algebraically too complicated. This does not limit our ability to do calculus. We're still able to do calculus even when we cannot explicitly solve for y. And the way we do this is called implicit differentiation. The basic idea is I am just going to take the derivative of both sides of the equation. I'm going to take the derivative of this whole thing, and then of course the derivative of 4, that will just be 0 because 4 is a constant. Now I'm going to take the derivative of each one of these terms separately. So constant and multiple rule, we can bring the 2 out in front. Notice that what we have is an x times y. That's a product. I'll need the product rule for that. And then of course I have the derivative here of x cubed, and this whole thing equals 0. Well, the derivative of y cubed, here we're using the chain rule. The outside function is the cubing part, the inside function is the y. So it's the derivative of the outside function, with the inside function plugged in, 3y squared, times y prime. Now here we have 2, and then we have a chain rule. Derivative of x, which is 1, times y, plus x times the derivative of y. And then, of course, the derivative of x cubed is just 3x squared equals 0. Well, now, once we've taken a derivative, now we could actually solve for y prime. So what we're going to do is just get all the y primes on one side of the equation and move everything else to the other side. So I have a 3y squared y prime plus a 2xy prime equals negative 2y and negative 3x cubed, 3x squared. Now I'm going to factor out the y prime, so y prime times 3y squared plus 2x equals, I'll factor out a negative sign on this side, 2y plus 3x squared. Now divide by the parentheses, y prime equals negative 2y plus 3x squared over 3y squared plus 2x. So we actually have an expression. Now, of course, the expression is not explicit in terms of purely x also. The expression involves both x and y. But for example, if we knew a particular point, so this function, for example, the point 1, 1, satisfies that equation. So the point 1, 1 is on this graph. And so that means we could plug in the point 1, 1 and find the slope. And when we do that, what we get is negative 5 over 5. So that is negative 1. So we know that at that point, the function has a slope of 1.